This is how to convert rational to radical exponents. First, you would take the variable and move it on the inside of the root symbol. Then you would take the denominator of the exponent, put it on the outside, and the numerator of the exponent put on the inside next to the variable. This is how you set up a rational exponent. So 7r to the 3 over 2 power, create the root symbol. 7r would go on the inside, the 2 would be moved to the outside, and the 3 next to the 7r on the inside of the root symbol. Alright, so let's try another one. Convert 11y to the 5/3 power. So you create the root symbol and put the 3 on the outside. Put 11y on the inside of the root symbol, put the 5 next to it. And this is how you set up your radical exponent. So let's try one more. Create the root symbol, put the 4 on the outside, put the 4 squared on the inside, but since this already has an exponent on it, we need to put it in parentheses. Put the 7 on the outside of the parentheses, inside the square root symbol. And this is your function. Here's how to simplify a radical. First, we take the number inside the square root and split it up into two different products. Then, you take those two separate products and split them up into two separate square roots. Finally, you take anything that you can take out of the square roots out. Anything that you cannot take out of the square roots stays inside the square roots. This is how to solve a rational equation. First, you would take anything on the outside of the root symbol and move it to the other side. Then, you would take that root symbol and set it to its equal power. In this case, 2. But you gotta make sure to do it to both sides to keep it even. Finally, you solve the equation like any other equation with an exponent in it by getting the exponent by itself. And that is your answer. So now we're going to solve a radical equation. First, you gotta get the radical alone. Next, you have to get rid of the exponent by setting it equal to its inverse. In this case, that would be 3 over 2. Don't forget to do the same to the other side to keep the equation balanced. And finally, solve the equation like you normally would. This is an example of an extraneous solution. First, get rid of the denominators by multiplying them by themselves. In this case, that would be x minus 2. Next, get rid of as many x's as you can. In this case, this would be 3x. Finally, get the x alone. In this case, you would divide by 2, leaving your answer to be x is equal to 2. However, in this case, x cannot equal 2, making it an extraneous solution. This is how to graph the square root function. With a number on the inside of the square root next to the x, you'd have to move this line up 5 on the y-axis. The number on the outside of the square root means you'd have to move this thing to the right 6 on the x-axis. This is your starting point, and that is your new line. For a cube root function, you do pretty much the same thing, except instead of only going in one direction, you go in both ways, to both sides of the x-axis.